Well, we are about to have a quick review on areas and perimeters, okay? Starting our geometry review. These are the very first things that I need to be super clear on. So let's start talking first about areas. Areas that I need you to know. Then again, in the exams like the SAT, you have on the very first page of each section, you have kind of a summary with the areas and there's Pythagoras there, a couple of things about triangles on the very first page. But the other exams, ACT, GRE, GMAT, you don't have this. So these guys of areas and perimeters is something that I just need you to know. So as a quick review, we have areas. Area, so let's start with the first one, the area of a quadrilateral, the area of a, let's say that is a rectangle. Imagine that these are 90-degree angles. So this is the length, this is the width. So here you know that the area is equal to length times width, okay? Some people, I'm gonna draw it right here. This will be a square, where this is x. So we know that the area of the square will be x times x, so x squared. But I want you to make a special mention here for you to keep in mind. Sometimes you will not see that people in these exams classify the square as a separate figure. And in reality, it is not that it's a separate figure. Let's say that what we need to understand is that the square is a special case, okay? It's a special case of a rectangle, okay? It's a special rectangle, basically. Special case of a rectangle. So at any given moment, you can have a rectangle, and they might say that the rectangle has all the sides equal, so we're talking about the square. But let's say that the square is classified within the group of rectangles, okay? Not for you to get confused, or eventually in exercises where I might decide to plug in, keeping that idea in mind might be useful. So we have the area of the rectangle, the area of the square. It's going to be important for us to know the area of the triangle. So let's say what this is B, okay? That's the base, and this guy right here, the distance, is what we call h, that is the height, okay? Something important here is about the height of a figure, not only about the triangle, but the height of a figure is equal to the distance from the highest vertex, okay? The highest vertex, this is important, perpendicular to the base, okay? That's the definition of height. Not only in a triangle, in any other figure. There's going to be another figure that I'm going to mention just in a minute that where the area also depends on the base. So we know what is the base, we know what is the height. So the area of a triangle will be given by base times height divided by 2. That will be the area of the triangle. Let's go immediately with the other figure that also the area depend also on the height. So is what we call a parallelogram, okay? So the parallelogram normally is a figure that looks like this, where the horizontal sides are parallel and these two other sides will also be parallel. So if this is the base, the area, again, the area of this figure is going to be base times height. That's it. Now, what will be the height? Remember the definition. Is the distance from the highest vertex, so I can take the highest vertex as this one, or you can take this one as well. They are on the same line, so perpendicular to the base. So it's like if you project the base here, and this distance right here will be the value of the height. And that is the height that we need for us to be able to find the area of a parallelogram, okay? Lastly, the other big figure that we need to know, the area, is the circle, okay? So let's see how is my pulse today. Oh, not bad. This is a circle. So remember that this, in a circle, this distance is important for us to know. The distance from the center to the circle is up to a circumference that is called r for radius, and we know that the area will be equal to pi r squared, being r the value of the radius of this circle. Okay, these are like the 5 basic figures, or kind of 4 basic figures I need you to know the area of, again, by heart. Even for the SATs, we know that they have all these equations on the very first page, but if you know them by heart, what will happen is that you may save some time. Instead of going constantly back to find the first page, you know, and you can move quickly. Now, as for the perimeters, where are the perimeters? There's not that much to say because it does not depend on in figure by figure. In any figure, any polygon that you're given, the perimeter is defined as the sum of all the sides, okay? The sum of all sides in the figure. So if you have a quadrilateral like this, so it's the sum of this side plus this one plus this side plus this side, okay? If it's a triangle, so, well, triangle, so this side is A, this side is B, this side is C, so the perimeter will be equal to A plus B plus C, etc. The only figure that we need to pay attention to, because the definition of perimeter is the sum of all sides, but in the case of the circle, it does not have sides. So what happens? Again, R is going to be important. So whenever we refer to the perimeter of a circle, is what in geometry you call the circumference. And the circumference is found with the following formula, is equal to 2 pi r. Okay, where again r stands for radius, that is this distance that goes from the center of the circle to the circumference, okay, to one point on the circle. And well, I think that that's basically what you need to know about perimeters. So I hope that this is clear, and let's continue with our very next topic.